Okay, in section 1.2, we're going to be talking about data classification. I've had some technical difficulties and I have made this video in its entirety twice, only to find out that it did not record. So the third time I'm hoping is the charm, but I'm also not going to rewrite out all of these notes for the third time. So I'm just going to scroll through the notes that I already had. So, data classification. There are two types of data that we're going to be talking about. One is called qualitative data, and that is data that involves attributes, labels, or non-numerical entries. So you might consider this like gender, hair color, eye color, political party, but also things that are numbers, although those numbers are just used as labels. So maybe jersey number or serial number or things like that. Then we have quantitative data, which includes numerical measurements or counts. So anything that you could tally or measure with some kind of tool or device. There are 4 levels of measurement that we're going to talk about. The first one is the nominal level of measurement. Now, the nominal level of measurement is reserved for qualitative data only. The data are categorized using names, labels, or qualities. So we can put our data into categories, but we cannot do things like put them in order. So we could use political party or things like that. No mathematical computations should be made. So it makes no sense to take my social security number and add it to your social security number because that's not going to be a meaningful computation, nor would it be advantageous to find the average social security number. So these numbers are just used as labels. Some other examples would be jersey numbers. We've already referred to social security numbers, movie genres, like I said, political party, gender, etc. Excuse me. The next level of measurement is the ordinal level. And we can have data that is qualitative or quantitative used at the ordinal level of measurement. This data can be arranged in order, but the differences between entries is not meaningful. So I could put things in order, like, for example, rankings. So if I wanted to look at somebody who was ranked number 1 versus someone who's ranked number 5, the difference between their rankings is 4. Now, I'm not sure that that has any meaning, but I certainly don't think that the difference between number 1 and number 5 being a difference of 4 has the same meaning as the difference between number 21 and 25 being a difference of 4. So you could do those computations, but they wouldn't really mean anything. The next level of measurement is the interval level of measurement, and that is reserved for quantitative data only. This data can be ordered, just the same as ordinal, but there is a meaningful difference between the entries. So if I wanted to subtract 2 data values at the interval level, then that would have some kind of meaning. Some examples are body temperature and year. So 2017 minus 1971 is 46, and so is 2046 minus 2000 is also 46, and that means there's a difference of 46 years, which I think we can all agree has some meaning. The difference between temperatures being 50 degrees is 20 degrees different than 70 degrees, and between 70 and 90 is also 20 degree difference. At the interval level of measurement, 0 means a position on the measurement scale, not a lack of it being there. So if I say it's 0 degrees Fahrenheit, that does not mean we don't have any temperature. That just means it measures at 0. Now we have one more level of measurement, and that is the ratio level of measurement. At the ratio level of measurement, we are going to be referring to quantitative data as well. It has all of the same properties as the interval level, except 0 means none of it is present. So if I have $0, that is not just a measurement of how much dollars I have. It really means I have no money, sadly. At the ratio level of measurement, you can form a ratio of two entries so that I could say that one thing is twice as much as another. So, for example, $100 is twice as much as $50. Now, I cannot do that with things at the interval level of measurement. So, thinking back to that, like temperature, it does not make sense to say that 100 degrees is twice as much as 50 degrees. Same thing with years. The year 2000 is not twice as much as the year 1000. So there's the difference between ratio and interval. Other examples, obviously we talked about money, but like monthly rainfall, things like that. So I have this little chart that we filled in, and it's going to ask you these questions. Like, it will help you to sort out whether your data is at any of these four categories. So the questions, the guiding questions are, is it meaningful to put the data in categories? Is it meaningful to arrange the data in order? Is it meaningful to subtract the data values? And is it meaningful to determine if one value is a multiple of another value? So at the nominal level of measurement, the only meaningful question is putting the data in categories. So that is a yes to that and a no to all the other questions. At the ordinal level, it's meaningful to put the data in categories and to put the data in order, but we should not subtract the data values or determine if one is twice as much as the other. The interval level, we can put the data in categories, we can arrange it in order, and we can subtract the data values, but we should not determine if one is a multiple of the other. And then the ratio level is a yes to all four of those questions. So you could use this chart to help you decide what type of data you are dealing with.